What's up, AP Psych? This is your lecture on experiments. And if you remember from the last lecture, I talked about how experiments are a type of research method, but they're so important to the scientific process. They're so important that they're going to get their own lecture. There's a ton to know about experiments. Sometimes when you're watching my videos, you'll be able to pause and look at all the bullet points I have listed in the learning targets, and that gives you an indication as to how important the lecture is, how important the concept is, and how much we need to learn. This is going to be one of those lectures that you probably come back to over and over again throughout this unit, throughout the year, and this is one that while I don't think it is complicated. I don't think it's hard, but it's complicated because there's a lot to know. So don't be upset if you make some mistakes or this one takes a few times to learn. Okay, so why are experiments so important? Why are they so valuable to researchers? Because they are the only research method that determines cause and effect. Here's a mouthful. Here's a bullet point I want you to write down. Experiments manipulate some factors to observe results while keeping other factors constant. There's going to be a lot of words that can be exchanged here. So factors might mean a variable. And so some factors might be the IVs, an independent variable. I'll teach that on the next slide or two. And then the results are the dependent variables. Again, I'll get into that more specifically to come. And then constants are often called controls. So what we can change, what we measure, and what we try to say keep the same. Okay. One of those bullet points, just to write it down. The more you learn, the more that sentence will make sense. Some famous psych experiments that you've possibly heard of include Pavlov's dog, Milgram's shock experiment, and Zimbardo's prison experiment. And if you have not heard of those, by the time you are done with this class at the end of our 2 terms, you will know what those are. Okay, so pause for a sec, pause your writing. There is nothing to write down from this slide. I am going to use the notes I gave you. You'll see that I divided them into the what, the who, and the how of experiments. And I'm going to, and I gave you a lot of definitions already. I'm going to use a practice experiment to explain all of these concepts. I gave you most of the definitions. So those blank boxes next to your definitions is where you should be writing examples that go along with this practice experiment. And that experiment is based on the observation that teachers are often crabby until they have their coffee in the morning. So we're going to start off by making a testable prediction, an if-then, a hypothesis about teachers and their mental processes or behaviors in regards to coffee. So I want you to think about that. What would make sense as a good hypothesis if we're talking about teachers drinking coffee and their crabbiness? We're going to start by coming up with that hypothesis, that if-then. This might be one that we could test. If teachers consume caffeine, then they will be happy. So write this down in that blank box next to the hypothesis definition. It's an if-then. My reminder, if you can squeeze this in as well, is that it must be falsifiable. To remind you what that means in this case, while I am testing this idea, if teachers consume caffeine, then they will be happy, I also need to be open-minded to the idea that if teachers consume caffeine, then they will have no change in their attitudes, or they might become unhappy. So there is just as much possibility that I could be proven wrong as much as my hypothesis could be proven right. So that's my hypothesis. Next, we need to decide on our variables and how we're going to measure them or define them, if you will. We have 2 variables. We have, it's coming. We have an independent variable, what I refer to as the IV, and we have the dependent variable, what I refer to as the DV. The independent variable is going to be the cause. The dependent variable is going to be the effect. The independent variable is the thing that we, as researchers, can manipulate, change, give to one group and not the other group. The dependent variable is the factor that might change in response to that and is being measured. Underline, highlight, star that word measured. This is the best way that you'll be able to tell the difference between the variables. The dependent variable is always the thing being measured, and we are going to always come up with a way to put a number on it. More on that in a second. In psych, this is often a behavior. Okay, I'm going to have you write some things in the IV and the DV blank boxes, but write them small because I'm going to have you follow up with a little bit more in the same box. So in the IV box, just put type of drink. Keep it kind of small. We're going to put something else in that box. And for the DV box, write happiness. If a teacher drinks coffee, then they will be happy. IV, DV. More that's going to be included in just a second. We need to talk about operational definitions though, because we're asking to talk about a type of drink and we're asking to talk about measuring happiness. These are very vague concepts that people can interpret in all sorts of ways. And because of that gray area that comes in with researching humans, we need to come up with some definitions that are very precise, specific, and clear. They need to be measurable, resulting in a number, and they need to be manageable, meaning I can actually test this out in my lab or wherever I'm going to test this. This is especially important on dependent variables, although we do operationally define any variable that we're working with in an experiment. But it's especially important on a dependent variable so that the results are quantitative data, in other words, a number. So how do we do that for happiness? How do you measure happiness? Do you measure it in feelings of love? Do you measure it in smiles? Do you measure it in, I don't know, that warm, squishy feeling that you get when you see your favorite person or your favorite candy? Well, none of those really result in a number. But if you look at this graphic right here, you might recognize this. This is what doctors use to measure pain. If you're a little kid, they might ask you which smiley face you're feeling. But really what they're trying to do is they're trying to put a number on something that is kind of vague so then they can analyze it and work with it. We're going to do the same thing with happiness in just a second. The point of operational definitions, though, one more time, is that you are trying to develop clear, specific operational definitions that allows other scientists to replicate the study, or in other words, do it again. And I want you to think back to lecture number 2. Why is that important? Why is it important for a researcher to replicate a study that's already been done? And if you don't know the answer to that question, make sure you ask me in class, because we should have covered that already. So in this case, the IV, our type of drink, we're going to very clearly and specifically define it as 8 ounces of Folgers Classic Roast Coffee. That is concrete, black and white, the same no matter which researcher decides to do this experiment. And then happiness, we're going to develop a rating scale from 1 to 10, asking someone's opinion on their happiness taken 1 hour before and after drinking the coffee. That before and after piece is really important because if we're claiming that the coffee creates happiness, we need to be able to show a measurement both before and after. All right, hopefully you got all that. On to the who. Who is participating in our experiment? Our population. Our population is the larger group or category of people you're researching. So in this case, it's just teachers. Easy peasy. A random sample is the small group of participants from the population chosen to actually do the experiment on. We cannot experiment on every single teacher in the world or even in America. So instead, we're going to choose a small group of teachers that we can work with. We are going to, because you see the word random, we're going to try to pick teachers without any biases. So what we're going to do, actually I'm going to pause while you write that down because I'm going to call. And I'm back. As I was saying, the reason we put all 55 pious teachers' names in a hat and draw a 10 is that everyone in the population has an equal chance of being chosen no matter what. There's no favoritism of my friend teachers or the teachers that I think are most crabby or most happy. None of that. It's all random out of my sample of teachers or out of my population of teachers. Then I need to look at my sample and make sure that it represents the population as it pertains to my experiment. So what I'm saying is a representative, sometimes we use the word stratified sample, makes up a small selection of all subcategories in the population. So here, I should probably make sure that my sample represents various age groups, maybe genders, that might not be relevant. And definitely people with all experience drinking coffee. I need to have young people, old people, people who have been teaching for a short time and a long time, people who drink coffee all the time and none of the time. It should be fairly representative. It's like a little snapshot of, if you will, of my whole population. So my little group of 10 should look in many ways like a small piece of my group of 55. Sometimes we might not have, the reason I said gender might not matter is we have to ask ourselves, does gender matter with how a person reacts to coffee? If it does, then that needs to be included in the representation. But if not, maybe gender isn't that important for caffeine consumption. That's maybe gender neutral. So that definitely is influenced by who it is and what it is you're trying to research. But before we continue on, we have to be aware of sampling bias. This is a sample taken based on the convenience of participants or those with strong opinions and is not actually representative of a population. So before I even go into that, ask yourself, does our experiment have a sampling bias? Did we pick our participants from a population because it's convenient for us? Or maybe we advertise coffee study and people are volunteering to participate because they think they can get free coffee. So do we have a sampling bias? Yeah, drum roll, please. Wow. Yes, we do. There it is. Yes, there's a bias. The bias is that we've only picked teachers at Pius. And maybe teachers at Pius drink coffee more than other schools because a lot of people bring it in and share it with one another. We've got open times where we can go grab a cup of coffee. That might not be true at other schools. Maybe at other schools it's tea, or maybe they're so busy that they don't have time to stop for a cup of coffee. So really, what we're researching is whether drinking coffee makes pious teachers happy. So the key point is that representative samples are like a snapshot, or should be, like a snapshot of the whole population in order to later generalize or apply their findings to everyone. That is one of those points where you write it down and then you might read it back and be like, wait, what? What I'm getting at is that if I only test teachers from Pius when I'm drawing my conclusions, then I can only generalize about teachers at Pius. So I'm testing 10 Pius teachers, so maybe caffeine does make them happy. So then I can say Pius teachers are made happy from drinking coffee. But I might not be able to say all teachers are made happy by drinking coffee if I've only tested my sample from this little small population instead of from a whole bunch of teachers across the wider population that I'm interested in which is probably all teachers. Okay. This is one of those points that we will go over multiple times because it is tricky. Okay, we got our who, we got our what, or we got our what, then our who. And now we have to talk about the how. How do we conduct this experiment? And what we're going to do is we're going to take our sample of people, our random sample of people, and we're going to randomly assign them into two groups, the experiment group and the control group. We'll get to that in our notes in just a minute. And what it means to randomly assign people is, first of all, this is something that must be done in experiments. If you don't randomly assign people to these two groups, it's not an experiment. So this is a step you have to take. And you're randomly putting people into these groups to prevent the impact of confounding variables. So this is another definition here. And yeah, put the purpose in the first box, and this definition of confounding variables is already given to you in the next box. So a confounding variable is something that will impact the experiment, but it's not really what you're trying to test. So think about it. What are some things that could impact someone's level of happiness while they're drinking coffee? Things like whether or not they've ever had coffee before, whether or not they have coffee on a regular basis, if they already believe that coffee makes them happy, the amount of sleep they got that night, their overall health, maybe if other happy things or sad things are going on in their life. When you pull your people to test them, people individually are going to have all sorts of things going on with them. Some will be the same, some will be different. But by mixing them up and randomly putting them into two different groups, it minimizes the impact of those differences. So you're going to have some people in both groups that drink coffee on a regular basis and some people that hardly ever have it, and so on. So the point of random assignment is that randomly assigning groups minimizes those pre-existing differences between the groups so that those differences don't impact the results. So it's like balancing it out. You're balancing out your people addicted to caffeine already and your people who are not used to it at all, or your people having bad days and good days. You're spreading it out so it doesn't impact your final results. Again, one of those pretty tricky points that we're going to talk about again. That random assignment, random sample thing, we will revisit multiple times. Okay, so as I was saying, we're putting these people into groups. One group is the experiment group, actually receiving the independent variable, and one group is a control group receiving the placebo or fake treatment. So in this case, our experiment is going to be the regular coffee with the caffeine in it. And our control group is going to get either decaf or brown flavored water. So they're going to think they're drinking coffee just like the other people, because we don't want them to know which is which. But then in real life, they're not going to get the caffeine compared to the other group. So this graphic might help you. So we have our whole population, and then through random selection, now I'm thinking I need to change that in our notes. We'll do that in class. We want to change random sample to be random selection. Probably have both words down, actually. And then that, from there, we randomly assign them to both groups, both the control and the treatment. What's the point is that both groups will be given some sort of degree of the independent variable. They will each get some experience of drinking coffee, but one is actually caffeinated and one is not, to fake them out on purpose, to make sure it's not just their mindset about the coffee, that it's actually the caffeine. Which brings us to the idea of blind research. You can either have single blind or double blind research. In single blind research, the participants are unaware of which group they are in, which prevents social desirability bias. We talked about that in a previous lecture, where you respond in the way that you think the researchers want you to respond. If you don't know what group you're in, you don't necessarily know how to act, if you should act hyper and happy or not. And double blind research. This is where both the participants and the researchers are unaware of which group is which, and this prevents experimenter or researcher bias. So the researchers unknowingly might influence the results based on how they talk to the participants. So in our first case, teachers don't know if they have coffee or a placebo. And in the other case, teachers and the researchers don't know which group has real coffee. Because the researcher might go up to that experiment group and be like, feeling pretty good today, huh? Scale of 1 to 10. What do you think? You feeling pretty alert and pretty awake? So even the way they act with the participants could be influenced if they know which group is which. So by making sure the participants don't know what group they're in, we prevent social desirability bias, where they're just telling answers that they think the researcher wants to know. And in double blind research, it makes sure that neither group knows, and so neither group can influence the other. And what's a placebo? I'm just using that word like you should know, right? Well, a placebo is important because what we believe can actually impact our behavior. So if we believe we're drinking coffee, we will believe that we're alert and happy and hyper, perhaps. So placebos are pseudo treatments, in other words, fake treatments, where a participant has the same experience of receiving a treatment, but they don't actually. So like our brown flavored water. We also have a word that kind of fits here, and it's kind of, I just stuck it here because I don't know where else to put it, and that is a confederate. You might have fake participants participating in research where they act a certain way so that the social context can be manipulated. So maybe you put someone, an actor, into a group, and so they can be like, man, this is a great day today. I feel alert, I feel alive, to see if that makes an impact on someone's perception of what they're experiencing. So the pseudo treatment in our hypothetical is decaf coffee or coffee flavored water. And then a confederate might be someone in the experiment group acting happy to see if just that influence changes how people feel. This is a video we're going to watch in class. Okay, last piece. How do you know the difference between an experiment and a non-experiment? This is going to be important in this class. You are going to be asked in a lot of the free response questions, is this research an experiment or not? Here are some ways that you can tell. In non-experiments, in all research, you should have a random sample. You should always pick your people randomly and not try to be biased to who you have participating. In non-experiments, you are making observations of the independent variable as it is to collect the dependent variable of data. You're not manipulating what people are drinking. You're not manipulating the temperature of a classroom. You're not manipulating meditation music in a stressful situation. You're not changing anything. You're just letting something happen, and then you're collecting or measuring information. You may use or collect existing data, and you're looking for relationships between things, not causes. In experiments, you have to have these things on this list. You have to have a random sample of your participants, and then you have to randomly assign them into groups. You need to have both an experiment group and a control group to compare them to. You need to be manipulating that independent variable, and you need to be controlling as many variables as possible, like maybe the size of the coffee. Everybody needs to get 8 ounces, whether it's placebo or the real coffee. It needs to all be in the same cup so no one can see in it and think it looks different. You need to manipulate the time of day they drink it. All these sorts of things. These are controls. You need to control as much as you can besides what you're actually trying to test, because that will help you set up that relationship between cause and effect, that it really is the coffee and caffeine making someone happy, perhaps, and not something else going on like the stress of the day or the time of day or the favorite cup that it's being served in. Okay, this was a doozy. This one of the few we've had, this is actually probably the trickiest lecture of this unit, and probably the most important. So please mark your papers up with questions that you have, and we will be sure to practice and go over many of these concepts, not just the day after this lecture, but throughout this whole course. All right, thank you.